Hello, sweet children. Back again with another video. So let's get it. So today we are quickly going to talk about solving systems of equations with three variables. So we shall start with, not doing that, we shall start with the simple case of where you have just three equations and it says solve. So we're going to do it by hand, we're going to do it with a calculator. Because who knows if it's on the calculator section or not. So let's do it. Okay, so obviously we know we have two methods. We can do substitution or elimination, which really, in my opinion, most of the time translates to you have a method of elimination, because elimination is almost always faster, especially when we're dealing with integer coefficients. But yeah, so your goal is to eliminate one variable at first. So if we add the first and last equation, we would have 7x plus c equals 6. So now we want to use two different equations to eliminate y again. So let's see. Let's do 2 times the top equation plus the second equation. So that would be 4x plus x, 5x. The y's cancel, and that would be 2 times negative z plus negative 3z, so negative 5z, and then equals 10. Okay, so now that we've done that, our goal is to eliminate one of these variables. So I could simplify this to 7x plus z equals 6 and x minus c equals 2, just by dividing that second equation by 5. So we can add these two equations and we get 8x equals 8. So x equals 1. If you look at that, in order for 1 minus c to be equal to 2, z has to equal negative 1. And then if we take both of those statements and plug it back into one of the original equations, we get, I believe, y equals 2. Let's see, 2 times 1 plus 2 plus, yeah. So that is solving a system of three equations by hand. Now remember, so if for whatever reason, I highly doubt HL Math would ever ask you something this straightforward on a calculator section, but if they did, remember you could write this as a 3 by 4 matrix. You've seen this before, but just a reminder. Then use RREF in the calculator. So RREF, remember it's under the matrix tab. And then it will spit out a matrix of the identity matrix on the left side. And then the answers on the right, which in this case would be 1, 2, negative 1. So you can practice using your calculator to get the answers. Remember, like the first column represents x, then y, then z. So this reads 1x equals 1, 1y equals 2, 1z equals negative 1. Okay, moving on. Okay, so now something less straightforward. Thank you, Ari. Something less straightforward. We have a system of equations, and we want to solve it in terms of this variable m that's inside it. So we'll deal with that m when we get there. We can't eliminate that m in any way. So we're going to start basically the exact same that we did before. So we want to eliminate a variable. So if you notice, it's going to be really easy to eliminate y by adding the first two and adding the first and last. So let's do that really fast. If I add the first two, I'm going to have 3x plus m. Oh, come on. Just don't want me to write an m. Okay, we'll come back to that in a second. There we go. M minus 1z equals 5. I just combined this term and this term, factoring out a z. Okay, actually for the next pair, I think it's going to be easier, because I don't want to use m twice. It'd be a lot easier if I do this second equation minus the third equation. So that would give me x, the y's cancel, and then if I subtract that, I would get plus z equals -2. Okay, so my goal now is to eliminate, wait, hold on. No, I don't want to eliminate because that's not really helpful. So what I want to do is now multiply the second equation by 3. I'll explain that in a second. I really hate m's. Okay, so here's an important fact of these questions. So if you notice, I have 3x here and 3x here. Now, for this type of question, there's two cases. Depending on what m is, I'm either going to get a set of, like an actual answer like we did before on the previous problem, or there's one situation, depending on what m is, that would give us no solution. And that is going to be if m equals 4, no solution. Now let's talk about why that is. So think about it. If m is 4, can you visualize that this left side of the equation would be exactly the same as this left side of the equation? Well, each of these equations is equal to a different thing, which would be a false statement. So it's impossible to solve the systems of equations if m was 4. Now, if m is not 4, we have a unique solution. And often IB wants us to write the unique solution in terms of whatever parameter we're dealing with. So I'm going to do that above. So let's go, we're looking right here. So let's just subtract these two equations. If I subtract these two equations, the x's cancel, but I have m minus 1z minus 3z, so that we could write that as m minus 4z, and that's equal to 11. So z is equal to 11 over m minus 4. So it's going to be a really ugly answer, but it's important that you see it. Sometimes it's going to be really ugly. So we're going to take this statement that we just found and plug it into here. So if we get that, then we get x plus 11 over m minus 4 equals -2. So x equals -2 minus 11 m minus 4. Real fast, if we wanted to do a common denominator, you can do this on your own. Let me do it in my head real fast. That would be -2m, is that plus 8? So minus 3 all over m minus 4. So now we're going to have to do the same thing for y. Hold on. Okay, before we do y, let's make sure we highlight what's important. So x, for any solution that works, is going to be that in terms of m. Z is going to be this. Okay, we have to do this one more time for y. Okay, please forgive my terrible editing, but here we are. It was just too many variables and I was going too slow. I just paused and did it. Okay, so all I did was I took this I took the second equation and replaced the x and z with what we solved in terms of m. Got here. And then I just isolated y, did a common denominator, and I got this. So if you want to pause and do that yourself, feel free. But let's circle back all the way back to what the heck this means. It's so easy when you're doing questions like this. It's like, what am I even doing? So what this means, so this was our answers for x, y, and z written as a point. So what this means is if you choose an m value that isn't 4, because remember 4 gave us no solution, no matter what m value you choose, so like 7, 18, a million, who cares, the solution to these sets of systems of equations will be this point in terms of m. So like say you chose 7 and you wanted to solve this system of equation, you can just plug 7 directly into here and that will tell you the solution to this system. Okay. I did not know when I started it that it was going to be so ugly, but here we are. Alright, so now back to the correct zoom in. This is one awful video. Whatever. Thank you, children, and thank you for watching despite my faults. Okay, so here we go to the last question, which won't take as long. So we want to find the value of k such that it leads to this system having infinitely many solutions, and then we want to find the solutions. Okay, so we do that by what do I want to say? We do that by creating equations that are multiples of one another. So often we would start this process the exact same way, but on this one we don't really need to, because if you look, 3y times 3 is 9y. Negative z times 3 is negative 3z. 1 times 3 is 3. If this k is 3 times larger than 2, then these equations are basically the same thing. So it's not super helpful and makes it impossible to narrow it down to just one unique solution. So k equals 6 creates an equation that is a multiple of the top one, preventing us from having a unique solution. Because really, at that point, we really only have 2 equations and 3 variables. So it's impossible for us to solve for a unique solution. But what we can do is solve for the set of solutions, which I believe in this case is going to be a line. Okay, so I'm running out of time, so I've written it out. I'm going to explain what I did to save time. So what I did first was I multiplied this top equation by 5 and wrote it down here, and then just rewrote the bottom equation. Then I added them together, and I had this equation just in terms of x or y. So remember, this is going to have infinite solutions, so my goal is to solve for all 3 variables in terms of one of the variables. So it doesn't matter which one we solve for here. I just chose to solve for x. It doesn't matter. But I'll explain that in a second. So if you solve this for x, you get this lovely pretty answer of 3 minus 22y over 13. So we're going to just say in the set of infinite solutions, x has to be equal to this in terms of y. So now I'm missing z, so I need to do something similar for z. So on this equation, I eliminated z. So next I need to eliminate y or x. It doesn't matter which. So I figured multiplying this top equation by 3 and this bottom equation by 2 was the easiest. When you do that, you get down to 5y plus 13z equals 1, which now I solve for z in terms of y. So now I have x equals something in terms of y, z equals something in terms of y, and I could write my set of infinite solutions x, y, z, and all in terms of y. We'll explain this more in class. Sorry, it's not my best video, but love you. Goodbye.